Alright, so let's go over this review sheet here. So number one, we have to factor, and notice that there is a greatest common factor of 2x. So I'm going to take out a 2x, which leaves me with x squared minus 8x plus 12, because everything divides by 2, and there's also an x. So when I keep going, what multiplies at 12 and makes 8? 6 and 2. So I got x and 6 and x and 2, and you guys like to make your puzzle here. So you get negative 6 and negative 2. Alright, so there's your factors. And then your zeros are going to be whatever, your roots are what makes this 0. So when you set 2x equal to 0, your answer, you divide by 2, you get 0. X minus 6 equals 0, so your answer is 6. And x minus 2 equals 0, then your answer is 2. So there's your three roots, 0, 6, and 2. Alright, so over here, again I have a GCF, but this time it's only an x. So I got an x, which leaves me 2, which leaves me 2x squared plus 13x plus 15. So once again, you factor this, you get 2x and x, you get 5 and 3. And the reason you get that is because you make your puzzle. 2 times 15 is 30. You got 13 in the middle, so you use 10 and 3. So x plus 10 and x plus 3 means, and I'm going to divide those by 2, so that's where I got these. Alright, so x and 2x plus 3, x plus 5, which means my x-intercepts are 0, negative 3 halves, and negative 5. Okay. Alright, so moving on to number 3. So number 3, I am trying to factor. These are perfect cubes. So remember, we have a little part, big part. What's the cube root of m to the third is m. And then what makes 27 is 3. 3 times 3 times 3. Over here I do square, multiply, square. So I square the m, multiply these together, and square the 3. Then we do SOAP. Same, so I use the same sign, then opposite, then always positive. Same, opposite, always positive. Alright, same idea here. Except what makes 8 is 2 times 2 times 2, so 2x, and this will be 5. Alright, so square the 2x to get 4x squared, multiply together, get 10x, square the 5, 25. And again, same, opposite, always positive. Alright, over here on number 4, we're going to just divide these using our synthetic division. So that means I'll put a 2 in the box, put a 2, a negative 1, a negative 3, and a negative 5. There's nothing missing. Bring my 2 down. 2 times 2 is 4. Add those up to 3. Makes 6. Add those up to 3 again. Makes 6. And makes 1. So that means that when you plug 2 into this problem, your answer is 1. So I can answer this question with a 1. And what is the quotient? Well, that just means we're going to be writing our answer. This was x to the third, so this is x squared. X and nothing, so my answer is 2x squared plus 3x plus 3 plus my remainder over what I was dividing by. Okay. Alright. On this next problem, number 5, we're going to be looking at the end behavior. Alright, so my end behavior is going to be based on my degree. So remember, the degree is the highest exponent that you see. So I'm going to circle that in each one of these. My degree here is 3, 4. I guess it's at front the whole time. So anytime I have an even function, even, it's going to look like this over here. It's going to be both going up or both going down. So that would be here and here. Now if it's a negative, those things that were going up have been flipped over. So they're both going to go to negative infinity. But down here, these are both positive infinity. When I have an odd power, odd goes opposite ways. Now normally, the right side goes up and the left side goes down. So that would be for letter C, because it's positive, so it's acting the normal way. So the right side goes up, left side goes down. Well, this means left side, so it's going down, and right side up. Well, this goes opposite here. So if it's a negative in front, then these things are get switched around. So the left side's going up, the right side's going down. Okay. Number 6, I have this W. I got 3 turns, so it's probably a 4th power, right? The roots, the zeros, the x-intercepts are -2. 1 is a double root, and then 4. So notice this double root right here. So when I write my factors, x plus 2, x minus 1 gets a double, and then x minus 4. Okay? All right. Switching over back here. So number 7, find the factors and the roots of this thing, synthetic division. So I look at my problem. I expect 3 answers. I see 1 right there. So I'm going to put a 1 in my box here. 1, -1, 3, -3. Leave a little space, bring this 1 down. 1 times 1 is 1. Add those up to 0. Get 0 again. 3. 3 times 1 is 3. 0. That means we're all good. So I have just proven that my 0, or one of my roots, is 1, which means a factor is x minus 1. Now, I need 2 more. Well, when I look at what's left right here, this was x to the 3rd. I don't see any more answers over here, so it must be imaginary. So this is x squared and x, and that's nothing. So we write this as an equation. X squared, I don't need 0x, plus 3 equals 0. So I have to solve this. So to solve this, it would be easy for me to just take away 3 from both sides, get x squared equals -3. Do my square root on both sides. Don't forget your plus or minus. The square root under the radical means you're going to have I, and then radical 3, we just leave it like that. So I knew they were going to be imaginary because I don't see them, and there we go. So you can just write them together. And so when you, oopsie, I was supposed to write that down here. So when you write your factors, you just do 1 plus and 1 minus. So x minus I radical 3 and x plus I radical 3. Okay. All right. Going next to number 8. On number 8, we have the graph of our function here. We have a parabola, and it keeps going, going, going. And some of you guys you need to label these points. This one's on the right side, but it's going down. It's on the left side, and it's going down. This point in the middle, 1, 2, 3, 1, 2, 3, 4. So the point 3, 4. So those are good to label because it kind of tells you a lot of your answers. Now my x-intercepts are my roots right here. I didn't label those, but that's 1 and 5. My y-intercept is right here at -5, so 0, -5. But when I start doing my increasing and decreasing in my domain and range and all this other stuff, I have all the answers here. So increasing, remember a positive slope is increasing, so it's this side right here. So remember we use the x values, so from -infinity to 3. So everything to the left of 3 is increasing. So -infinity to 3, always parentheses. And then the right side has a negative slope, so from 3 over, so from 3 to infinity. Also look, x value, x value. Domain. So what's the smallest x here, and what's the largest x? Well, smallest, largest. Also this graph is going out forever. Okay, so -infinity to infinity. My range, it goes down forever, but it doesn't go past 4. So also look, here's my lowest y, and there's my biggest y. So -infinity to 4, it touches 4, so bracket. All right, end behavior. When x is -infinity, there it is. There's your y. When x is +infinity, there it is. There's your y. All right, so both ends are going down. Okay, so let's see. Y equals, my center is 3 and 4. So we need x minus 3 squared and plus 4. That makes us move to the right 3 and up 4. I do need a negative in front because this thing has been reflected. And if you check the parabola, it's just your normal, like 1, 1, 2, 4. All right, so it hasn't been stretched or shrunk at all. So it has a normal pattern to it, normal width. All right, let's see down below. So some radicals that we have started. So remember, anything that I bring out is going to multiply with what's already there. So let's start breaking down this 54. So that's 9 times 6, 3 and 3, and 3 and 2. So I have a group of 3's. So 3 is coming out. So 3 is coming out. There's already a negative 3 there. So let's plan on that being a negative 9. 3 times 3. All right, I have an x. Now let's see. 3, oh, let me leave a little space. Put my cube root back and put that 2 back in there. So I'm done with the numbers, the coefficients. So 3 goes into 6 twice. So x squared is coming out, but there's already an x waiting. So that'll be x to the third. And there's none left. 3 does not go into 2 at all, so y2 is just going to sit right where it is. All right, with letter B, let's multiply these together first. 3 times 5 is 15. Let me put it over here. Square root, 18 times 2 is 36, x squared, y is y squared. All right, so let's take a look at these. Square root of 36. Now you could break that down, but I also know the square root of 36 is just 6. So 15 is going to multiply by 6 when it comes out. That makes 90. Nothing left. This is a square root. 2 goes into 2 one time. 2 goes into 2 again one time. So those all come out, and my answer is nice and clean. All right, letter C. I got 81 to break down, so we'll do 9 and 9, and then 3 and 3. So look, there's 4 3's right there, so there's a 3 coming out. So there's a 3 coming out, leave a little space, put my radical back. There's no number left inside because 81 is all used up. 4 goes into 8 twice. So x2 is coming out, there's already an x there waiting, so that would be x3. 4 does not go into 2 at all, so y2 is stuck inside, and this other y, I didn't really change it, so there it is. Okay, on this last problem here, these two radicals match, so I may put those together, but he's an oddball. So 3 minus 5 is negative 2, radical 2, and then plus 4, radical 3. And that's all I can do. Here, these need to be reduced first. So 8 is 4 times 2, and then 2 and 2. So I'm going to bring out this pair of 2's. 2 times 3, so it's negative 6. So this problem becomes negative 6, radical 2, because of 2 left over. 32 is 16 times 2. The square root of 16 is 4, so I could bring that out now, or keep breaking it down. But if you broke it down, you would get 2 sets of 2, so that's 4. So this is going to be 4 radical 2. And the 27, 9 times 3, and then 3 and 3. So a pair of 3's comes out with the 5, so that turns into 15, because they multiply, and then leave the 3. So once you're looking around again, it's kind of similar to letter A. This guy is an oddball, the other two go together. So negative 6 and negative 4 make negative 10 radical 2, minus 15 radical 3. Alright, this last guy here, looking at letter C, I know that this guy will never go together with anybody else because he's a cube root. And the cube root of 8 is actually perfect. It's a 2 because 8 is 2 times 2 times 2. So this is going to be 6 times 2, which is 12. This 12 here I'm going to reduce 4 times 3. So there's a 2 coming out, 2 times 4, so it's 8 with a radical 3 left over. Square root of 16, oh, I don't need to break that down, it's 4. Alright, so oddball. And so when I look at this, 12 minus 4 is 8. 8 plus 8 radical 3 is what I need. And that is it. I'll see you in class.